All right, server authentication students. We have a little optional video at the tail end here that, like I said, I'm probably going to place it after the labs and not actually make y'all add this to your labs unless you really want to. We talked about a purely stateless implementation and the pros and cons of that, and I mentioned a stateful implementation with the pros and cons of that. JWTs, JSON Web Tokens, are normally meant to be completely stateless. That's what they're made to do. They self-take care of themselves, right? They expire themselves. They have their own secret signature. They have their own payload and claims that can be verified. And if that payload isn't expired and it has the right signature, I told y'all, we just trust it in our JWT strategy down here. What if I did want to take some kind of stateful approach? Two things we can take into consideration. Do I want to store the token or do I not want to store the token? We can do that. Before we call done null payload, or rather when we create our tokens, for example, and this would be a good use case of moving the create token to its own function, we could take into consideration that before we send the token as a response, I might say await db.tokens table if I had one, insert this token as well as who it belongs to with a foreign key to make sure that information is set in place. And that way I can say insert this info to a tokens table so I can track who has what token out in the real world. That is a distinct possibility we could do. And that would be the same thing over here in that login router if you wanted to implement that functionality and that feature, and which means down here, we would also have to say, like that, and say db.tokens.find and take the payload user ID, for example, and make sure that that person has a token in our tokens table to make sure that's in sync. And if that happens to be the case, you could also say the same thing we did up in our local strategy, which is then take that user's ID and try and find it. And I realize that it should probably also be like that if we had that column in that, if they had a tokens table. Find their ID in the users table with the payload.user ID. That way it all stays in sync. Rather than have to track the tokens table, let me show you a simple, stateful way to implement this if it's something you just want to know how to do and want to see the basics of how to get there without having to pivot too much of our current code base as is. But remember, this does come with some overhead if every single one of your token checks, which could be on many different endpoints, is now beginning to incur another query on top of what's going on. But remember, that is a pro depending on the scale of your application, but can be a con if not a big one. So let's check out what a stateful approach may look like. I'm going to choose to take a piece of that payload, specifically the user ID of who this token claims it belongs to. And I want to look up some information about that user. So what I'm going to do is say const user record equals, remember all select statements will return an array, so I'm going to destructure it right away. Await db.users.find and wrap the payload in that right there. It needs to know what column we're trying to find, and there we go. Need to add the async keyword here. There we are. What are you fussing at? Type string. Oh, ha! I can't believe I made that goof way long ago and now it's coming up as a bug. In my users queries, notice I said this is going to be a value of always string. I mean, it could technically be a number, so let's give ourselves, it could be a string and number type. I mean, it could be one or both of those. Type never, oh wait, hold on, let's union type. Yeah, my bad. So it's going to be a union of string or number, so there we go. Right. That way we can find someone's ID in the users table. Now, how does that help us? I mean, honestly, well, first off, just like up here in the local strategy, we can say if user record is undefined, if there is no user record, or if there is one, if that user record exists, then I could consider that being, okay, that means we're good to go. And rather than just doing the payload, we can now change it to the user record. So it's the most, rather than passing just the payload anymore, it is the user record just like we had up here. So it's the same kind of thing now, right? And we can say if there is no user record or something else went wrong, check this out, we can go to our database and do something else. So we can say otherwise, done, null, false. Remember, if we're doing custom error handling, we can say a info info message that went wrong of something like, I don't know, we can say, you banned LOL or something like that. Something went wrong. Like when it ran this check and their user is gone, then they're probably banned LOL. Otherwise, if their user record's still there and it's all fine and dandy, then they can continue on like nothing's changed. So let's see how we can actually ban someone pretty quickly. Well, I mean, there's a ton of different ways to do this. I'm not going to say this is the best way to do it, but check this out. What if I simply alter that users table, alter table users, and add a column? Add column. We're going to call it the banned column. It'll be a tiny integer column because it'll be one of two numbers. 0 if they're not banned, and 1 if they are banned. Tiny int, default number 0, and I'm going to have this column after password in the list. Like that. Because I don't want it after created at, I want it after password. I want created at to be the bottom column. So update that, select star from users, and check it out. That's why I said after password, so the banned column in between appeared in between those two. Because I'm a picky little guy. What can I say? I'm picky. I like having things in a certain order, you know what I'm saying? So we're going to leave it right there with banned at 0. But now that that is a part of my users table, don't forget to update your user records. I always leave myself a sticky note saying update user record or users table model when I start changing things around. So I don't have to say banned number. I can actually tell TypeScript it's going to be one of either 0 or 1. There's no other choices right there. So that's actually a specific cool TypeScript thing to know how to do if you have a specific set of values that a property could be. It's not just all encompassing numbers. It can either be 0 or 1 only. So I can say, and if the user record dot banned equals 1 or 0, because that means they're unbanned. Might want to mark down which one, or you can do y or n with the character variable. But yeah, if their banned status is 0, let them continue. Otherwise, they banned. And that's the pro of stateful logic, is that we can take this information in real time every time they make a request, and when they're no longer, when we want to ban them, we come over here and ban them, and boom, the next time they try and use that token, sorry, you banned. And that is the brilliancy of that stateful logic, having that yoink, that rope tied to their key that we can pull back whenever we want. So let's check out an implementation to see how that works. First off, I probably broke the crap out of everything, so let's test with register here. Still works, right? And it's running a query every time it does that now. So let's go to the database and say, we don't like this guy anymore, so we're going to ban them. I'm going to go ahead and update that value to be a 1 instead of a 0. And now, real time, we just banned somebody. And that's the pro of a stateful approach. I'm not going to require the lab to be done this way. If it makes more sense to you and you seem to enjoy it, just remember what this workflow is and the flip side that comes with it. If you have a ton of people using your application, probably not for your projects and personal side gigs you're doing, this is a good approach to do that's nice, safe, and secure. And the stateless one is what you see in larger scale applications and enterprise level applications. So I think it's important you'll know how to do both and have at least seen both. So this little optional video, remember, optional, not part of the labs in our course, just shows you one potential way of adding this authentication workflow to go from stateless to stateful with minimal refactoring. And you can, the sky's the limit from there. Like I said, having a tokens table where you store these along with the user which has a foreign key gives you yet another way of checking things and keeping them in sync per request. Ta-ta for now.